So this video is about objective 2. I can decide if a function is linear, exponential, or quadratic from a table, graph, and equation. So last week we looked at this and we looked at tables and we compared how linear looks in a table, how an exponential function looks in a table, and how a quadratic function looks in a table. So we're just going to review that real quick, and then we're going to look at how they look in an equation and also in a graph. So when you look at a linear table, you want to look and see, do I have a common difference? Am I adding the same amount the whole way down? Because you're looking to see if you have a constant rate of change. So I see to get from 7 to 9, I need to add 2. To get from 9 to 11, I need to add 2. And to get from 11 to 12, I have to add 1. So at first thought, we're like, well, that's not constant. It changes at the bottom. So before you can rule it out as linear, you want to make sure you look at your x's. And I see that to get from -2 to 2, I add 4. To get from 2 to 6, I also add 4. And to get from 6 to 8, I add 2. Remembering that linear functions have a slope that is the same, that's your common difference, I know that the change in y over the change in x would be 1/2. And then 2 over 4 would also be 1/2. And 1 over 2 would be 1/2. So while it doesn't look constant down the y's, since the x's correlate with that, we know that we do indeed have a slope of 1/2. When you look at an exponential function, you want to see a constant ratio of change. So you want it to be multiplying by the same amount every time. So I see that 1/4 times 16 is 4. Again, you can get that by doing 4 divided by 1/4, which is the same as doing 4 times 4, which is 16. 64 divided by 4 also gives us 16, and 256 divided by 64 only actually gives us 4. So now we see that we didn't multiply by the same thing the whole way down. Exponential is slightly different. It doesn't work like a change in y over x like linear does, but we can see that to get from -2 to 2, we add 4. To get from 2 to 6, we add 4. And to get from 6 to 8, I add 2. If we can think about it, 4 times 4 is 16. And to get from -2 to 2, that's 2 jumps of multiplying by 4. So we know that the common ratio, or it will actually be constant because the change is the same. To get from 6 to 8, that's 2 jumps multiplying by 4, which would be 2 times 2. So that's how we can know that our R value, or our common ratio, is 2. When you look at a quadratic function, it's a little bit different. And what's confusing to some people is that quadratic still looks like it's adding, but it's not adding a constant amount because 1 plus 3 is 4, 4 plus 5 is 9, and 9 plus 7 is 16. I notice that my x's are indeed going up by 1, which is what makes this not linear. I'm not adding the same amount every time. But we can see that from 3 to 5, that's adding 2, and from 5 to 7, that's adding 2. So from there, we can conclude that there is, in fact, a pattern. If I wanted to get to my 5th x, I would just need to add 9 to 16 to get 25, because I would just need to add 2 more to 7. That's what makes this quadratic. This second difference being constant. A linear graph is actually or a linear function rather, is just a function that grows at a linear rate. So because this first difference is not constant, but is growing by a constant amount, that makes that growth linear, which is what makes this quadratic. There is no common ratio or common difference that goes along with a quadratic. We just, at this juncture, need to make sure we understand that if my second difference is constant, I have a quadratic function. When we look at a graph, if we have a linear function, it will form a line. Line is in linear, so that really shouldn't be a stretch. So we see that we have this straight line, which makes this, that was supposed to be blue, that makes this a line. So the graph forms a straight line. You see the slope in the line with the rise over run. So that's how you know it is linear. If the graph forms a curve, and we'll start being more specific to calling it an exponential curve, then we know that our function is an exponential function. There will usually be a y, there will always be a y-intercept, but you are really not actually touching this x-axis. It's really just getting as close as it can to it. In a quadratic function, we'll start to see that it forms this U shape. That U shape we will call a parabola. And what makes a quadratic different from a linear or an exponential is that quadratic functions can both increase and decrease. In fact, they will both increase and decrease. If we remember back, linear and exponentials, one of the biggest things they had in common was that they both only increase or only decrease because they're changing by a common difference or a common ratio. So they can't go both up and down. But since a quadratic doesn't actually have a common ratio or common difference, it can both increase and decrease. And that's what gives you that U shape. They can also flip over and be kind of an upside down U as well. When we look at an equation, a linear function will have the highest degree be 1. So we learned earlier this week that if it's the highest exponent is 1, so it's just an x term is the highest, then that makes it linear. So it comes as no shock that y equals 1/2 x plus 8 is linear. That's also in that slope-intercept form that we've talked about in the past. Remember, we've also looked at standard form as well as point-slope form in the equation form as well. So that y equals 1/2 x is that slope-intercept form. We could also have ax plus by equals c, and we could also have y equals m times x minus x1 plus y1. Those were all other forms of linear equations, standard form and then point-slope form. If we're in an exponential function, then our x is in the exponent. Exponential, exponent, x in the exponent, that all goes together. It's a lot of x's. So y equals 2 to the x is that general form. We also kind of looked at it in that a times b to the x as well, so that if that y-intercept wasn't 1. In a quadratic function, the highest degree will be 2. So we learned that polynomial with degree 2 has the degree is quadratic. So y equals x squared would be our quadratic. And there will be an x squared term. Could also have an x term and a constant, but it will definitely have that x squared term. We'll see later that the standard form of a quadratic is ax squared plus bx plus c. That a term has to be a number other than 0, because if it is 0, the x squared term goes away, making the function no longer quadratic. Now you're going to complete the practice on sorting types of functions. Follow the directions at the end so you can submit that to your teacher. There are videos in there on how to complete it. Have a great day, guys.